This next set of lectures for lecture set 17 will look at a few aspects of C programming that are more involved and more complicated than the things we've seen before. Mainly we will look at pointers. So the big thing in this set of lectures will be pointers, and then after that strings, which is related. And after that, we'll look at input-output, printing things to the console or terminal, printing things to files as well. And then we'll look at how to link programs and use of the make command or the make utility in Unix. Okay, so first we start with pointers. We talked about this very briefly in the previous video. And essentially, a pointer is an area of memory. A pointer describes a memory address. So if you have a variable I, int I, and set it equal to 1, you can think of it as some location in memory being set to the value 1. And we saw the previous video that ints, since they're 4 bytes, and since memory addresses are usually shown a byte at a time, and this is not always the case, if they are shown a byte at a time, then an int which has 4 bytes will take up 4 slots. So it'll have 4 addresses, but it's the most significant byte that's addressed. And so in the case of value like 1, what you will see is that there will be 3 bytes that are 0. So each one of these digits is a single byte. So 2 digits is a single byte. This is a single byte, and then over here you have the value 1. So this is all taken together. A set of 4 bytes has to be used to store the value 1. Now off to the side over here you see number with one letter, F, and whenever you see something like this, whenever you see a number with the letters A, B, C, D, E, or F, then you know that these numbers are hexadecimal, that is base 16. Base 16 numbers will have all of the usual numbers, that is 0 through 9, and then also the letters A, which denotes 10, and then B, C, D, E, and F, which denotes 15. So this is base 16, or hexadecimal, and F is 15, 8, 7, and 0, and 3 have the usual meanings. Okay, so this is just an illustration. This is just an example. We assume that the address of I is 30F870. So every variable in a C program will have some address, and we're just assuming that the address of this particular variable I, an int, is 30F870. So this next address, the address of the next byte will be 30F871, and then this will be 872, 873. So 4 bytes for an int. The most 3 significant bytes in this case happen to all be 0, and the last byte has the 1. So if you go beyond 256, 256 is what 1 byte can hold, then you will see these other bytes change in value from 0 to something else. Okay, so let's say we have 2 things that we've declared, int I and int star j. So you might say, what is int star j? Well, int star means j is a pointer to an int. And what exactly is a pointer? A pointer is the memory location where something is stored. So in this case, we're saying int I has the value 1, and that we saw before, assuming that I has the address, I starts at address 30F870. You'll see 4 bytes, which holds the value of the int I, and the int I has the value 1. These 4 bytes are taken together. And this pointer j is a variable that stores a memory address. So j If you look into J, what you will see is a memory address. In this particular case, we say that J is assigned to have the address of I. So that's what this ampersand symbol means. Ampersand I means get the address of I, store that address into J. So now if you look over at what J has, so this is J. This first 4 bytes, this is I. This next 4 bytes is J. Will it always be like that? Yeah. Most of the time, if you declare 2 variables side by side and they're both exactly 4 bytes long, they will be right next to each other in memory. So this will be, let's say, in the stack. This, when you declare variables, every variable you declare will show up in the stack. In this case, I and J will both be in the stack, and J will have the value that is this address. So the address of the most significant bit, most significant byte of I will be stored as the contents of J. So if you put these together, 0030F870, that's essentially this address address of I. Okay, so once again, a pointer is a variable that stores a memory address. So J over here is declared to be a pointer to int. This is how you declare a pointer to an int. You say int star J. And in this particular case, we're assigning the address of I into J. And so what we're doing is we're taking this address 0030F870, store that into J. So this is all assuming that addresses are 32 bits. Things change a little bit if you have 64-bit addresses, and so if you have 64-bit addresses, of course you'll have, rather than 4 bytes, you'll have 8 bytes. Okay, so just like other variables, a pointer has a name, a value, and a type. So the name of, in this particular case, J being the pointer, is J. The value is, in this case, the address of I. The type is int star. So it's not just int or star, it's int star, and int star means pointer to an int. And as this shows, this is often shown as J having an arrow going from it. So the contents of J is an arrow pointing to the first byte of I, and that's why we say that J is a pointer, because we look at it as a pointer going from inside J into this other location. Just so happens to be that the contents of J is actually a pointer to the previous 4 bytes. So in general, how do you declare pointers? If X is a valid type in C, the declaration for a pointer variable that points to an instance of type X is X star, whatever type X is. So it can be a double, it can be int, it can be a char, whatever type that it's pointing to, followed by a star, and then the name of the variable. So this is just like a regular type declaration. So you have a type and then name. Just so happens that this type is a pointer to some other type. So for example, int star J is a pointer to an int, char star K is a pointer to a character, and double star L is a pointer to double. There are some conventions to declaring pointers. It's often people will use int star and then space and J. You almost never will see int and then a space and star and then another space and the name of the variable. But often you will see int, space, and then a star in the name of the variable. All of these do the same thing in this case. However, you do have to be careful, because although it looks like the star goes with the type, it actually goes with the name. So keep that in mind, and we will see situations where this will be important. In this particular case, each one of these lines do exactly the same thing. Okay, so remember, pointer declarations have a type followed by a star indicating that the next name will be a pointer to something. However, also note that the star goes with the variable, not the type. So for example, this will be where you'll get some differences, and you might be misled into thinking what J and K are. So if you have a declaration like this, if we just focus on this particular statement, although it looks like J is a pointer to an int and so is K, it is not. K is just an int according to this declaration. If you want K to be a pointer, you have to use star K. So that's why we say that the star goes with the variable name, not with this type, even though it is quite commonly shown as being type star. The interpretation according to C is that the star goes with the variable name. And so in this case, the star goes with the J, and it says J is a pointer to int. In this case, there is no star next to K, and so K is just an int. If you want K to be a pointer, not only do you have to have the star for J, you have to have a star for K similarly. So with this second line, K is a pointer. So remember that and save you a lot of trouble in debugging. Two very fundamental pointer operators are the ampersand, which you can read as the address of operator, and the star operator, which you can read as the value at operator. So if you were to see the star, you would read this as get the value at the thing pointed to by P, add 1 to it, and store that in J. That's how you would read this particular line of code. On the other hand, if you see something like this, star I, you would read this as get the address of I, store that into P. So ampersand, whenever you see that, if you want to try to figure out what this operation is doing, you want to read that as address of I. If you see a star, you want to read that as value. What is the value at location pointed to by P? Get that, add 1 to it, store that in J. Okay, so two very basic, very fundamental operators that's used with pointers. So when we say star P, in a declaration, we're saying that P is of type pointer to int. However, when we say star P on the left-hand side or on the right-hand side, what we're doing is dereferencing. So this is called dereferencing. It's saying I'm going to take the pointer P, I'm going to find the thing that it's pointing to. That's called dereferencing. So when you say star P is equal to 1, let's ignore the rest of the statements. Just taking a look at this, what this is saying is take the thing that P is pointing to, and in that value, in that whatever P is pointing to, store 1 there. So for example, in this particular case, we set x equal to 0, and we say that P is a pointer, and P is going to get the address of x, that is, we say that P is pointing to x. And when we say star P, we're basically saying whatever P is pointing to, which happens to be x, we assign the value 1 to it. So even though between here and here we don't change the value of x, we set x equal to 0, by the time we print it out, we print out what x is, it will have changed because we set whatever P is pointing to 1. So try this out and make sure you understand why x has the value 1 at this point, even though all we did was assign 0 to it.